Hey, hello, Techstars. Welcome to Tech Up Podcast. In this episode, we are going to see about how we can cool down the Earth. Yes, we can cool down the Earth by various technologies, and we are going to see about its pros and cons. The record number of fires burning across Brazil's Amazon rainforest has prompted renewed global outcry over climate change and in big spending. $5 million from Leonardo DiCaprio, £10 million from the UK. Meanwhile, Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that will cool down the Earth. It's called solar geoengineering, and it's highly controversial. It would look like something like this. Thousands of planes would fly very high and use nozzles to inject millions and tons of light reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth. Back in 1991, Mount Pinatubo erupted in Philippines. It was the largest eruption to affect a densely populated area, creating avalanches and giant mud flows that left more than 700 dead and 30,000 homeless. It also spewed a cloud of 20 million tons of sulfur dioxide particles into the stratosphere. That chemical cloud was hundreds of miles across and reflected about 2% of the sunlight back into the space. And in 1992, the Earth was cooler than in 1991. This is a part of the mechanism, but we do this in a controlled way. Modeling studies have found that it could reduce the intensity of heat waves. For instance, apparently, it could reduce the rate of sea level rise. It could reduce the intensity of tropical storms, but it also comes with significant risks and uncertainties. Things like mass famine, mass flooding, drought of kinds that will affect very large population. It could also weaken monsoons in India, China, and Africa enough to affect the crops. It could eradicate blue sky also. You start increasing the amount of diffuse light and you have less direct light, which is the same thing as saying as it looks like hazy and white. And if the global community decides it should stop. So you stop injecting it, and after a year the cloud is gone and you get this rapid warming at a rate much faster than you would get it if we had done nothing. If you have taken out the greenhouse gases that are adding into the warming, then the temperature won't go up and stay what it is. So, if we don't stop emitting greenhouse gases into the atmosphere, we don't try as hard as we can do that, then there's no point in doing solar geoengineering. A 2016 opinion poll conducted by the Harvard Group doing solar geoengineering research found that 67% of subjects support its use. One reason this technology is appealing is cheap. One study estimates that it would cost an average of $2.25 billion globally every year for the first 15 years of deployment. Compare that to the $500 billion the US government estimates it would cost just the US by 2100 if no action is taken against climate change, or the $1.6 to $3.8 trillion projected global spending by 2050 on low carbon energy production. You can also compare it to direct arc carbon capturing technology, another climate change solution backed by Bill Gates and by big oil companies. It involves sucking billions of tons of carbon out of the air at $100 to $200 a ton. It could be a big business. Solar geoengineering, on the other hand, is so cheap that nobody currently stands to take money from the process. But just because a solution is cheap doesn't make it a good one. It's cheap, but it's dangerous. It doesn't require a lot of materials. It doesn't require big innovation. It basically affects the whole planet with one project. So that is not necessarily a situation that has a lot of profit opportunity, right? Because there's not going to be a lot of different people that can do it and compete in a marketplace. Bill Gates is among a dozen individual donors and 14 foundations backing the first stratospheric solar geoengineering experiment out of Harvard. It's called Stratospheric Controlled Permutation Experiment, or SCOPEX. A high altitude balloon will lift instruments about 20 kilometers into the stratosphere. where it will be released less than 2 kilograms of different naturally occurring chemicals like calcium carbonate and sulfates, and then measure the change in atmospheric chemistry and light scattering. The Harvard group that runs the Scopex and other experiments has raised more than $60 million, more than double any other solar geoengineering effort. And annual global funding has gone up to $1 million in 2008 to $8 million in 2018, with the majority of the funding coming from the US. The first phase of Scopex will cost around $3 million, with much more needed for wider research on solar geoengineering. To this point, stratosphere injections have only been tested with climate modeling. In the UK, a government-funded solar radiation management test called SPICE was cancelled in 2012 because of the issues with patents. A study last year found that no existing aircraft can inject the stratosphere at a high enough altitude. But developing a new high altitude enough tanker would not be technologically difficult or prohibitively expensive. Nozzles still need to be designed that can continuously blast out trillions of particles, and scientists still need to decide what chemicals those particles should be made of. But unlike cloud brightening, which is another solar reflection technique, the tech needed for stratospheric injections is not far off. The technology is not the main thing that's holding this back. The main thing that's holding it back is the uncertainty about what the exact effects would be, and the positives and the negatives of its effects, and the governance and decision making process for implementing it. Other radical attempts to control climate change have been tested in the past, like when one California businessman dumped 100 tons of iron dust into the Pacific to spawn the growth of carbon absorbing plankton. But unlike small and sometimes rogue experiments, planet-wide solar geoengineering will require buy-in from international community. In the simulations, we found China got warmer and drier relative to the past when you stabilize global temperature, and India was now cooler and wetter. So you can see there how international relations around using this technology could become complicated. I mean, we can't decide on what to do about the emissions of greenhouse gases. And so, how are we going to decide on settling the planetary thermostat? Does this real concern that we won't be able to reach agreement, we being this entire planet? And so, there's the prospect that countries just go ahead and do solar geoengineering, and that causes disagreement, conflict, tension, and even possibly a war. 3 years ago, the international community did come together when almost 200 countries signed the Paris Agreement on climate change, agreeing to limit global temperature rise to less than 2 degrees Celsius. Since then, President Trump has stated his intent to withdraw from the agreement. The Paris Climate Accord is simply the latest example of Washington entering into an agreement that disadvantages the United States. The global emissions are not being reduced fast enough to reach these goals. We know what we should be doing. What we should be doing is reducing carbon emissions. So we are creating a moral hazard. We are providing out for you where you can all say, well, I'm going to fix this technology instead of doing the ethically right thing to do. It's way too early to give up on much more ethical approaches to climate change. If future generations were literally in the room to question us on how dubious arguments are, we wouldn't get far with some kinds of arguments we are trying to offer for neglecting conventional climate policy and going down this path. For now, the failure to rapidly reduce emissions has prompted more exploration of alternative solutions like carbon dioxide removal and solar geoengineering. But scientists warn we still need to reduce emissions too. If you're not cutting out CO2 emissions at the same time, from my perspective, there is a little point in doing this because you would have to start using ever increasing amounts. No responsible scientists say that it's silver bullet. All the responsible scientists say this is something that we deploy if we had to do, alongside all other stuff that we are already have to do. The US Academics of Sciences is holding a series of meetings to study solar geoengineering, including one at the Stanford this month. The committee will issue a report next year with the recommendations for how or if solar geoengineering research should continue. Some scientists say the research is necessary in order to arm future generations with the ability to enact this backup plan even though it seems nearly impossible now. We ought to start working on the solar climate engineering problem right now with as much urgency as we can, so that if we want to deploy it in a decade or so. We ought to start working on the solar climate engineering problem right now with much urgency if we want to deploy it in a decade or so. We understand what we have to do. This is a real moral horror, especially in a situation where we are not doing all the things that we have to do along to minimize the risks of climate catastrophe now. But experts do agree that more public awareness is needed around solar geoengineering because within a couple decades, for better or worse, it could be part of the solution, helping return the planet to pre-industrialization temperatures. Modeling evidence gathered over the last decade has pretty consistently found that a moderate amount of solar geoengineering could significantly reduce many of the impacts of climate change. But it can't be a solution because it doesn't return the climate system back to how it was. It doesn't do anything about things like ocean acidification. So whatever happens, we have to cut out our CO2 emissions to zero. So right now, we need more research to understand this better and a broader conversation so that all the world's nations have a seat at the table when this is discussed. Hope you understand how we can cool this earth by this technology, and we need to think about it and reduce the CO2 emissions. Thank you.